Alright, sorry I'm being lazy and filming a monitor. I mean, I did draw it on here, but... God, every time I start to talk, my voice... This is called the Trilidar mouse, which is dumb, because these aren't lidar, they're time-of-flight ranging sensors. Point is, it's not like a laser, it's a freaking, like, infrared. It's a piece of crap, is what I'm saying. These emit like a massive cone. I forget the degrees, like 25 or something. The idea is, this is not to scale, like you have to figure out a decent distance. It's a trackpad really, but it also has right and left and right clicks. So yeah, you're like, you know. But it's part of what are these things called? Cyberdecks. I'm not like a huge person into that. I like, you know, functional things, ergonomics, you know. But I gave away my like MacBook, which has served me well. It's a 2015 i7. I gotta get another one that's like more. It's newer, so it can run this like Xcode, the simulator, without dying. The 2017 one can do it, but it's just super slow. Like, unfortunately, time marches on, you know. Yeah, and then these are the components. Like, this is a 68% profile type keyboard, which is, I think, my favorite kind of keyboard so far. I like this arrow keys being here, and then the top row. I don't like it when there's like either a gap or like other keys up there. Like escape has to be at the very top left for me. I don't like this keyboard because the profile is like that versus like a concave, you know. It's weird. Like, I don't know why they did that. Whoever made that. But yeah, this is a 8 gig Raspberry Pi. A friend got it for me as a gift, and it's Pi 4. But yeah, so I'm pretty much just making like a laptop with this external screen here. Have to 3D print like a hinge thing, whatnot. I mean, I kinda don't really want to do this project, but whatever. Since I'm giving up my spirit. Damn. This screen on this NEX5 is messed up, man. The glass screen protector's chipped. Yeah, anyway, that's the project. Oh, I'll talk briefly about this. These things run like I2C. Just plug those into the Pi, but the thing is, each one is gonna fire like at an offset. So this one goes, if something bounces back, figures out how far it is. Next one goes, how far is it? Next one goes, and then you should be able to get positioning, you know, from that. If you just had two, like the cone, it's not enough, you know. Yeah, it's not enough because you're only getting a dimension. Like, that's like the best thing you could hope for. That would be crazy. You put this thing on a spinning, what are those things called? The contact part spins. Anyway, yeah, you put one there and then the whole thing spins. And your finger, like, that would work, but yeah. Although you'd have to have some kind of like positioning encoder thing. No, a Hall effect sensor would work. Like, put them fixed on the outside. That's just complicated. Like, why, you know? But anyway, yeah, so that's that. And then I'll have to figure out the code for that, but that'll be fun. It's possible this thing won't work at all just because these things are trash. But, you know, I'll figure that out when I figure it out. So these VL53L0X sensors apparently have a beam angle of like 25-30 degrees. And I'm having them arranged in a triangle, equilateral triangle. and the goal is to track your finger like a trackpad. This tech isn't really new. Like a common one is like they have this horizontal line, vertical line, and it tracks where your finger intersects. But I don't have one of those special edge sensor things. But I've worked with these before. I thought about trying it. It's for a like cyberdeck thing. I'm not really a huge fan of those, but I've had this like Pi 4 sitting around when I use it. I'm just saying I'm not a fan of them because like when you make a laptop yourself, it's usually like bulky as hell. I like thin laptops. But anyway, yeah, so the thing you have to consider is, yeah, like minimum cross section. And the other thing is the cone, like, I don't know if it hits the ground. If you're looking at sideways like that, the cone, you know, it's three-dimensional. If it points at the ground, I think it'll just skip off. And they're arranged in a equilateral triangle, but they will fire like in a circle, not at the same time. Because like if this one fired, that one would pick it up. You know, so you have to offset them. But yeah, the main goal is just to get X and Y coordinates though. So you're like, that would, let's see, what would that do? Looking at a cursor. Well, if I put my finger down and I go that way, the cursor would go that way. You know, like that's what you're trying to do. And then I'll have two buttons down here, like left click, right click. It's really like not ergonomic, but I didn't want to have like this cyberdeck thing and then there's like a hole where a mouse is or something. Like that would be, I don't like that. And I didn't want like something loose that I had to keep track of. Yeah, that's what I'm trying to do. I ordered 3 new boards. I didn't think I had like 3 on hand. These are actually different. Like these two are the same. I'm not sure who made these, but it's different. Oh, it says V2. Yeah, it's different than this one. Maybe I should have bought more of the V2 than these. I just want them to be like the same, so there's no like weird discrepancy or whatever. And then the other thing is Raspberry Pis. I believe they have 2 I2C buses, and these sensors will have different addresses. I mean, maybe I can use a different one for that reason, but I may have to use like the SPI interface for one of the sensors, and then use, you know, one sensor per I2C. Or I have to connect a microcontroller between these guys and then the Pi. So then microcontroller will control all of these and then talk to the Pi. So I'm just gonna print like a basic test jig. It'll be like a triangle thing to hold these after I do some dimensions in SketchUp. And then I guess I'll wire it up and start writing some test code to see if it works. So this is like a representation of how these things work. They have like a 25-degree field of view. So you can imagine like a beam coming out like that. And you take 3 of them and arrange them in a triangle, and then your finger goes like in between all the beams. I'm gonna make like a cross section of a finger. Oh man, the other thing that's bad is you your finger, when it goes in there, it's like probably angled. So if like a beam is like that, your finger's angled like this way, then that'll be a shorter distance than if it was here and angled, you know, that's a farther distance. That'll be interesting. But it's one of those things where like the feedback is direct, like you're watching the mouse and seeing it move, you know. Yeah, so it's something like this, and then it's got to be like a size that's not insane. Maybe a area like that, but I think even this is pretty massive. I don't know. So this circle here is a 3-inch diameter circle. That's like that big. And you see there, like, that's not big enough. Like the cross section that the finger will cross is so small. Like the effective working area is like in that area right there. So I'm gonna have to make this even bigger. That's the downside of this thing's form factor. You have to have like a massive surface. I thought 25 degrees would be massive, but it's actually not that big. You want like a really wide angle beam for a smaller size. So I guess I'll make it even bigger. I guess, I don't know, I'll try like 5, maybe 6. That just sucks. Like look at how massive that is. Like this is your finger. 3 is there, and it's like, alright, that's pretty cool. Like that's probably what you'd use on a trackpad normally. I could go out to 4. 4 is probably even bad. 5. 5 is not terrible. I don't know. Yep, I'll keep messing around. So here's a 6-inch diameter circle, and I think what I'm... oh dang, I undid the group here. I think what I'm seeing is, let's say that's there. That's like the finger. This is the like ideal diameter right here, because that's like no blind spot. Like here, that's a blind spot, blind spot, blind spot, blind spot. You know, so having it bigger than that, I don't think is going to be helpful. Because if the ring is like every area of it is covered by a beam, then you can put your finger like anywhere and get something. And that appears to be, let's find like an intersection. Crap, I gotta hold shift. 1 sec. That's like 1¼ inch. So it's smaller than a 3-inch area. It's like 2½ inch. It seems like really small, but I don't know. 2½ is like right there. So your finger's like right here. That way. I think that's pretty good. It's not like a MacBook trackpad size, but you know. So I'll go for that for the test print. For the test programming and making sure it'll work. Oh damn. So this is me not understanding how geometry works. It has to remain this big. But the effective area is a inner circle. I'm gonna have to like design the pad to make that obvious. Like only put your finger here. Yeah, like the smaller the radius, you know, the smaller the intersection. Yeah, duh. So it is gonna be freaking absurdly massive. Well. So I've been doing some more modeling. I won't be able to print this today because I gotta do a bunch of stuff after in like 40 minutes. But tomorrow I'll print it. And then the new parts won't come in till Wednesday, unfortunately. Today's Monday. But I'll be able to like start prototyping and writing code with what I have though. So I actually have 3 of them, but they're just different like brands, different boards, so. But anyway, I've just been getting dimensions. Like these are the stands that the board will screw into. I'm using these servo screws. See if I can focus it on my hand. Yeah, these are servo screws. They have like a really wide head. So they'll grab the thing and pull it towards the plastic. Anyway, yeah, and then just looking at these these cones, and then that like ideal 2.5 inch diameter circle cross intersection. The tallest height is here, which might be like overkill, but I'm using that as like the highest, or the height to set the sensors at, like from their emitting point. That's like the z-axis. That's the preferred coordinate I use. Like this blue axis here would be z. Anyway, yeah, so I'm just gonna design like a ring thing that I can print and then attach the sensors to after they've been wired and start programming with that. Alright, I am struggling to work on this project. It's because I'm distracted with life. Me making bad decisions. Oh damn, this one's wrong. Yeah, so here you can see how it's gonna look. There's gonna be like a base ring, and actually I was thinking about it, I'll draw like a pad here so I know like where my finger should be. But the other thing is I'm gonna printing like large areas takes a long time. What I'm gonna see about doing is like changing the height. It's a cone, so like, you know, it gets wider the farther away it is. And as you raise this up, it chops off more of the area. I guess. Yeah, I mean, I use like the lowest area over here, or how high these things are. I don't know. I mean, I guess the nice thing about it is like it's gonna be like a bowl shape. If you like know where your finger's supposed to go, but yeah, I'm gonna fix this one. Alright, so here it is without the sensors. This is like equilateral triangle, so 120 degrees per section. So I'll have to print that and then solder and wire. I may take advantage of if they show up as different addresses, like different brands, I'll use that over using SPI and I2C at the same time, or a microcontroller.